Hello out there. Today I have with me Koushik and Shiva, and we are going to talk about design patterns. Koushik and Shiva, welcome.
Thanks, Ranga.
Thank you, Ranga.
Design patterns is one of the things, as a starting programmer, we think a lot about. There are a lot of questions in our minds. What is design? What is architecture? What is the importance of design patterns? How do I learn it? Is it important to learn design patterns? And we also asked our YouTube community uh, their questions on design patterns, and there are a lot of questions which came in, like what are design patterns? How important is it to learn design patterns? And also, like, from an interview perspective, and also how do you apply these design patterns once you learn them practically, and also where do you start with learning design patterns. So there are a wide range of questions. Probably, like, when we talk about design patterns, I see two words in there. One is design, the other one is patterns, right? So probably we can get started with talking about what is the difference between design and architecture. uh, Kaushik, do you want to give an overview of what's the difference between design and architecture?
I'm going to attempt an answer. I don't know if it's the scientific difference. I'm sure if you go for like some scientific literature, they will have this. Now, this is the precise difference. But
Right.
here is how I reason this in my mind. An architecture is what comprises of the individual pieces that make up a working application, and this can include things like certain services, certain data statement management, like some kind of a database where that exists. What is the communication and coordination between all those different things, and how you have a system scale. So you're basically looking at it as system level, right? How is the system created, and how the components of a system interact.
Absolutely.
Design, on the other hand, is a little lower level than architecture. At least in my mind, I'm looking at design as, okay, now given a component of a system, how do you make that component work? And this could be, at a unit level, maybe elements of code like classes. How do those classes interact with each other? How are classes created? How are they destroyed? How are you planning to make that code base more maintainable and extensible? What are the different things? Like once you know what a problem is, there are 100 different ways to solve it in the code, right? So you have certain criteria and certain favorable outcomes that you want from how you've designed your code. So that's where you would use different designs to write your code so that you meet those favorable outcomes. So at a high level, that's how I think about it. Architecture is
Hmm.
big picture. The whole
Right.
application, components of the application are product, and the design is basically, given a component, how do you make it work, and how do you achieve some non-functional requirements for it.
Okay, so architecture is at high level and design is at more at a low level, details kind of thing.
Yeah,
Shiva, how do
and
you see it?
the thing is, like, it's the terms are blurry. Sorry to cut you off there. The terms are blurry because nowadays people talk about system design as basically what we used to talk about as architecture, right? Where you are technically designing a system,
Right.
which is
Right.
precisely the definition I said. Architecture is basically how a system works. So if you're
Exactly.
designing an architecture, then this whole thing, difference between architecture and design, is lost there. So it really depends
Absolutely.
on how you apply the term. In a classical way, this is how I've been thinking about these two terms. I don't know if you have anything to say differently, Shiva.
Yeah, I also get confused, because people use different words in different contexts. But because there is a confusion, I stick to one understanding of my own. So when I think about the architecture, I think of it as a blueprint of the whole system without any technical details. When I say blueprint, okay, what are all the components are there, and how do you one component interacts with other. So at the very high level, and it's not technology specific, it is mostly technology agnostic. And when I think about the design, like I think in terms of a technical design, where you go a little one step closer to the implementation part, where okay, you are going to deploy on say some cloud platform. Okay, you want to have a file storage. That's what you mentioned in the architecture diagram. But when you talk about the technical design, you say S3. That's what I'm going to use as a file storage. So like that, from the high level blueprint, when I talk about the technical design, I go a little bit specific to my implementation part. So that's how I see it. But
Okay. Okay.
again, when I interact with people, they interchangeably use architecture versus design, but I stick to my understanding.
Okay, nice. Actually, interesting perspectives. The way I actually think about architecture and design is architecture is decisions which are difficult to change, and design is decisions which are more easier to change. So, because I found like a lot of this confusing, and especially with the evolution of agile, I felt a lot of architectural decisions are made as part of the Scrum team, and there should be difference between architecture and design, and that's the definition I came up with. I thought, okay, if something is easy to change, probably that's a decision you can make in the sprint. But if something is difficult to change, like a framework you choose or something like that, that's something which should do probably in a technical sprint or something where a lot of thought needs to go into it before you make. So the way I would think, like the way I was actually thinking about architecture is things which are difficult to change. You need to put a lot of effort to make that decision. So that's what is architecture. And things which are at a class level, probably things which are more easier. I mean, nothing is easy to change, right? It's all relative. So whatever is relatively very, very difficult to change is architecture. Whatever is relatively easier to change for me was design. But again, as we are discussing in here, it's blurry, right? Each of us have our own definitions of how we look at architecture and design. And probably I think one place we can look at is uh, how architecture patterns are different from design patterns, right? So when we talk about design patterns, typically we are talking about classes, their interactions, how do you design each class. And probably when we talk about architecture, we are talking about components, how components interact, what is the kind of messaging and things like that. Maybe that's a place we might look at.
I think there is a historical bias towards it, because why do we think about classes and objects when we think about design patterns? My theory is design patterns became really popular because of the Gang of Four book, right? So that's like exactly right. So everybody learns about design patterns, and they look at the patterns in the Gang of Four book. People don't often realize that they are talking specifically about object oriented patterns. That book
Absolutely.
is not design patterns, period. The Gang of Four wrote a book about object oriented design patterns. So,
Yeah.
what has ended up happening is they have popularized a first set of patterns which are applicable to object oriented programming.
Mm.
And because the book became so popular and synonymous with design patterns,
Yeah.
people started associating design patterns with object oriented patterns. But if you think about it at a higher level, the definition of design patterns can be anything. It can be functional
Absolutely.
programming patterns, right? That could still apply. It is
Yeah.
just a side effect of that particular book kind of making the concept of design patterns more mainstream. Just my theory, but it
Absolutely.
holds good considering what they actually started out doing.
Absolutely. I think, yeah, I agree with you there. I think uh, if you look at design patterns literature, I think the first one which was really, really popular was the Gang of Four book. And I guess, and it probably stuck with us. The interesting thing is, this book is not easy to read, right? I mean, I actually tried to read this when I had like 2 years of experience with Java, and it was very tough. I would say probably not more than 20 to 25% of what the book says I was able to understand. And so yeah, it's like the thing is, like, to be able to make sense of design patterns is not easy. um, okay, I think we started discussing with architecture versus design, and probably we'll get into probably patterns, right? So what is a pattern, and kind of where do we see patterns and things like that? Shiva, do you want to start with that?
Sure. Yeah. So when we look at the applications that we build, usually the kind of features we implement, they don't drastically change from project to project, task to task. Many times we see similar patterns. Okay, we get data from some other system. We do some kind of a validation. We persist into some DB. So by and large, we do kind of a similar things in most of the applications. And of course, the business logic would change from application to application. So these bright minds, they sit together and then identify these common recurring patterns, and then they identify what is the best possible approach, and they came up with these various patterns to follow. But the interesting thing is, as you said, if it is say 20 years back, most of the times people were writing C, C++, and Java and all those things. and then they were applying all those patterns to build the software in a much better way. But over the time, these patterns became core components of most of the languages or frameworks. These days, I don't see anybody writing a singleton from scratch. If in Java world there is Spring Framework, which you don't have to write actually implement a singleton, you leverage Spring features. Even some languages like Scala, they have this inbuilt into the language. Like you don't have to create singleton. Singleton is provided by the language itself. So if you notice, the languages and then frameworks evolve to a stage where we can just use those features. You don't have to implement them from scratch. So that's
Absolutely.
how I see the design patterns. They got matured to an extent where we can see them as a primitives of the framework of the language. But again, if you truly understand those components and design patterns and all those things, sometimes you may have to come up with your own composite pattern where you use underlying those design patterns. So there, it is required to have a good understanding of these patterns. Yeah, that's how I see design patterns.
Cool, cool. So, Kaushik, do you want to talk a little bit about patterns?
Yeah, patterns are very interesting. They're a very concrete way of somebody who has already done stuff and who's wise and who has learned to tell somebody who's new, well, I have done these things in the past. These things
Right.
worked, these things didn't work. So trust me, do things these way. Because one of the things that tends to happen for a newcomer is like, it's almost like a superstition, right? Okay, why are these guys telling me to do it this way? It is just kind of like a distilled
Ex-
learning of the best solutions to commonly occurring problems, right? So they were like, yeah, this problem, we've seen it before. We have tried all these different things. We found that this one solution works best. So
Right.
for this problem, apply this pattern. For this other problem, apply this pattern. It's basically result of a lot of experience. And this is true for the Gang of Four book as well, right? So they had a lot of experience building software and they
Mm,
kind of distilled the common problems that they faced and the common solutions that seem to work for the most part into those things. So that's how I look at design patterns,
absolutely.
recommended solutions to common problems.
Exactly. Exactly. So, if you're looking at a house, uh, typically these days we have a hall, we have a bedroom, we have a like, so that's also a pattern kind of, right? So like it's not like almost everywhere you go you would see the same thing. There are obviously a lot of advantages of doing that, right? So when somebody is getting started, probably they don't understand all the things that they would need to take into consideration to make a decision, and that's where these patterns can really help. Any other places you see like patterns being really useful, Kaushik?
Yeah, I'm sure it's a lot of places, but I'm trying to think where we see patterns. So traffic is one thing that comes to mind, right?
Absolutely.
Traffic
Yeah.
coordination. There are a bunch of patterns. They're like,
Yeah.
okay, you have how intersections are designed, how the stoplights are designed, crosswalks and stuff like that. The sidewalk is a pattern, right? Allow people to walk on the side of the road, have traffic go
Exactly.
on them. Like these are all patterns, and it's almost like you can think of it as the things that you see are common implementations of patterns. So we kind of think of it becomes second nature to us when we imagine a road with a sidewalk. We
Mm,
automatically imagine the road is at the center, the sidewalks are on the sides. What is
exactly.
that? That's basically a repeated pattern for a solution just applied over and over again. So we almost think of it as second nature. So yeah, I think there are patterns all around the world, all around us.
Absolutely. And they also give you a common language kind of, right, to
Yeah.
speak and things like that.
Exactly. So I tell you I give the name sidewalk, and you immediately know what it is and where it is located, and it's like
Exactly.
yeah, that makes sense.
Absolutely.
Yeah,
Perfect.
in the software development, right? These days, those patterns are so much built into the languages and frameworks. People are not even looking at them as a separate thing or some kind of a improvement because that's what they are starting on their careers. Like they start using them. So an interesting observation I had was a while ago. I have a team member who is just started as a software developer, and then they started using Spring Boot, and they were using JDBC template to talk to database. And I was very enthusiastic about Spring Boot, and I told them Spring Boot is super awesome and all. And he came back and said, "Yeah, it is good, but I don't see why you are so excited about it." So
Yeah.
then I understood, okay. I asked him to go back and then implement the same database operations using plain JDBC. And then he said, okay, I'll go back and I'll come back in an hour. And then he came back next day. And then he said, I understand what you are saying. Because Spring JDBC template have this template pattern implemented so beautifully. You don't have to do all this acquiring connections, starting transactions, committing, rollbacking. That's all shielded away from you, and you just write the business logic. But when somebody started using straight away with JDBC template, who never used plain JDBC, it's hard for them to see what is the beauty of it. So next day he came and he said, he didn't say anything else. He said, I understand what you mean by it.
One of the code review checklist elements which I had when like we were directly having JDBC was to check if the connection is closed or not. If the exception try catch block was perfectly implemented with the try, because we had severe problems at that point with connections not being released and the application server needed to be restarted because of flaws in the code. And today, yeah, it's a pattern which helped us avoid, right? So once we start making use of JDBC pattern, we are thinking at a high level and not really probably focused on the low level details at all. Cool. Awesome. So like I think we are we have touched upon a little bit about what's the difference between design and architecture and the role that patterns play. Like patterns are basically kind of way of somebody to share their experience with somebody who's getting started newly, and these help us to have a common language as well, right? So um, like coming to like somebody who's like your experience of using design patterns, right? So like when we talk about patterns, you have design patterns and architecture patterns. Probably we'll focus on the design patterns aspect of it right now. um, Kaushik, do you want to like give your experiences with respect to learning design patterns and using design patterns?
Sure. I'll start with learning design patterns. When I was new to the industry, there was a lot more emphasis to design patterns than there is today. Maybe because of what Shiva mentioned right now. These days, you don't tend to think about like, okay, I need to apply these design patterns now. You pick a framework, and the framework already has applied that for you. So, but at least when I was starting out, there was a lot of focus on it. So, for example, singleton patterns, right? We had to create our own singletons because I don't think Spring was my first framework. I don't even remember what I was using there. So we didn't really have an easy way to create the spool of objects, singleton objects, instances that we can look up. So singleton was definitely a commonly used pattern for minimizing resource wastage. So if a singleton will do and it's an expensive resource, well, you got to use a singleton pattern so you don't have
Absolutely.
duplicates. So like that, there were a few patterns that were introduced, and I honestly don't remember what my first patterns were when I started learning it, but it was very much need based. Like, okay, you need to do this, so go ahead and learn those. So from there started my journey, and I used to read and learn a lot even then. Not as much as now, but it was there. So that's when I started my journey and looked into the Gang of Four. The book was impossible to read. I totally agree with what you said. But yeah, there were other material online where people had written articles and explained it. So that was how my journey started. And then from then, learning about frameworks has allowed me to see design patterns applied, and that helped me. So this knowledge of design patterns helped me understand frameworks and decisions that they use and why they do it. Like the JDBC template is a good example of a template pattern. It's like, yeah, this is
Absolutely.
what they're doing and this is why they're doing it. Like you can immediately catch that. And
Exactly.
I think it helped me learn the framework and also apply the framework better, because it kind of makes sense of the reasons why a framework is designed in a certain way. So that's been my journey through design patterns, need based to just casually learning a little bit more, to appreciating applied design patterns and saying, hey, this is why they did it, and kind of coming back full circle. So yeah.
Absolutely, absolutely. I think, yeah, it's that journey is very, very interesting, right? So where you start really appreciating the design patterns is once you like know a little bit about it, and to know a little bit about it, you have to spend a lot of time uh, trying to figure out what it is. Shiva, anything you want to add? Anything there?
Yeah. So when I started as a Java developer, right, in 2006, design patterns is a must know for any interviews or even for tech discussions. Like there is a lot of focus on design patterns. You know that pattern, you know this pattern. So there is a huge importance for knowing design patterns. But
Absolutely.
when I try to read in the internet and all, they are kind of a very canned material. Like, okay, this is how you can create singleton. This is how you can use so and so pattern. But I kind of can't connect how exactly we can use them in a realistic projects. It's kind of a very theoretical. So what I did, I at that time we were using Struts framework, and then I kind of explored the source code of Struts, where you have front controller design pattern, you have MVC, and even there is a singleton pattern where it automatically loads all the Struts configuration. So all those patterns they have actually used for implementing their framework. So that's when you can get a realistic hands-on experience of, okay, theory is something else, but you have to see how it is practically used in the frameworks. So
That's true.
another thing is most of the applications use some kind of a database connection pool and all. So again, I went to check for there is a Commons DBCP library which creates objects and all. So again, I explored that library, how it is actually implemented. So my learning is more like reading some design pattern. If it is not clear to me, I try to see is there any library or frameworks they are using it, so I can get a realistic view of, okay, this is how they can be used. And the next best thing I did is before, I think, while Rod Johnson created this Spring framework, right? It is based on the book, the J2E Development and Design, some book, where he actually described various thought process and then how he implemented those ideas into the Spring framework. That is the
Absolutely.
best book I would suggest. But these days, people say we already have Spring Boot and it is already doing. Why do I need to learn all these things? But if anybody is interested to learn those fundamentals, that is the book I would strongly recommend. Where he very well described how he think about the problem, how he approached to solve it, and how he actually implemented. That is the best book I have ever read.
Oh, I completely agree with you, Shiva. That was one of the first books I read with respect to like J2E patterns, right? So, like when we talk about design patterns, and like we are talking generally in terms of Java patterns, but the J2E patterns, like at that particular point in time, were kind of the in thing, and I was struggling to understand. And the expert one-on-one development with like I think J2E kind of, right. So it was actually the book based on which the Spring framework came. And yeah, absolutely, that was a wonderful book, and I guess that book played a big role in how I think today. I think that's a great book. But one another book I would recommend, if somebody is actually starting to learn design patterns, is this one. I found actually the head first design patterns was much easier starting point, especially if you are at a starting stage in your career, right? You don't know a lot of things. Like it's written in a much simpler language, and it kind of helps you understand why there are patterns and things like that, right? One of the, like we have been talking about different patterns, right? But these patterns come not just as a result of experience, but also as a result of applying certain good principles or good practices with respect to programming, right? So how do you see like like what are the important principles that you would focus on when you are starting to work on something, Kaushik?
Um, Honestly, these days when I'm trying to design something, I don't go like, okay, what pattern do I apply? There was a phase in my career when I used to do that. Like, okay, oh man, yeah, man, it's been a while since I've applied the strategy pattern. But no, it's more of like, this is what is the recommended way to do. You look at a problem and then you work towards a solution. And while you do that, you see if there are any um, any of these common patterns that fit, and if it does make sense. um so yeah, I really don't know how to describe, because design patterns is not kind of like front and center in my mind these days. It's
Exactly.
more of once you start applying it in enough times, I guess it becomes second nature.
Mm,
And sometimes I write code and I make a design, and then after a while I go, well, okay, this is actually a pattern, but you don't tend to think about it at that time. So it's just
absolutely.
constant application kind of makes it second nature. So I don't know. I know I'm not giving you the answer to your question, but this is basically how I process it these days.
Perfect. No, that's awesome, right? So when actually you are looking at a design pattern, when you are trying to learn it, probably the important thing is to understand the context in which that pattern is applicable. Like getting a high level overview of the context and a high level pattern. Maybe the implementation details are not so important. Is that something how you think as well, Shiva?
So I totally resonate with Kaushik because you read about design patterns and you understand them, but you don't actually go approach a problem thinking, okay, let me apply some pattern to it. Actually, when you look at the pattern, the problem, it some way rings a bell saying that problem looks like you might want to use strategy pattern. So you
Right.
don't go approaching with a set of patterns that you want to apply, but looking at the problem will tell you, okay, what is the most suitable pattern to use.
Absolutely.
That's how I see it. Just problem has to tell you what pattern you might want to use. And
Absolutely.
then again, I see again we all did that mistake of learning all those things and trying to apply every pattern that we know.
Yeah.
Hopefully, we are not doing that anymore. And again, how do you choose and what kind of a patterns I actually implement? Again, depends on the problem at hand. But recent times, as I said, most of the patterns are built into the languages and frameworks. But recurringly, what I see is most of the times we are integrating with various other systems, and suppose we are getting data from various other sources and their formats might be different. So that's where we go with the adapter pattern, like we read data from various sources but internally we want to store in unified way. So that's where we can use adapter pattern. And again, many applications have some kind of a customization of some algorithm. Okay, you want to use say payment process or whatever, so there may be a strategy pattern. So
Mm.
very few, I hardly write some design patterns because most of the times it is already there built into the languages and things.
Absolutely, absolutely. So, as probably as a beginner, like somebody who's starting to learn design patterns, right? Based on our learnings, I think probably what they can focus on is understanding the situation, like what is the right situation for a specific design pattern, and not so much focus on the implementation details of the design pattern. So that when there's a right context, it should appeal. I mean, so when I'm solving a problem and when I see that kind of a situation coming up, that's when I would go and apply the pattern. Is that a right summary? Like, how do you see that, Kaushik?
Yeah, no, that sounds fair. You do tend to see these common problems come up again and again, and once you've applied the pattern, it becomes second nature to you as well. But here is another pattern. Excuse the pun, that I'm noticing in my application of design patterns, is that you know when the Gang of Four book was written, again, this is just my theory, not validated by an expert, so take it with a pinch of salt. I feel like when the Gang of Four book was created, they were dealing with code bases that would last 20 years, 30 years. They were thinking about longevity. Okay, they wanted to make sure a piece of code can live for a long time, and they had this kind of a value system where they were willing to add a little more complexity so that the code can live a long life. Okay, so like a little bit of complexity now is okay, a little bit of over engineering is okay, so that the code can live longer, right? I think the industry as a whole has shifted a little bit over there, right? Code these days don't live for more than 5 years, and people tend to keep refactoring, keep changing. New technologies keep coming up.
Absolutely.
So these days, people tend to think more about like, okay, is this code easy to understand? Is this code easy to maintain? Is this code easy to change? Because guess what's happening a lot to the code? The code is being changed, right? So as a result, what I've noticed is some of those patterns don't apply. I think I talked about it in a previous call where we used to have this pattern about interface and implementation, right? So we had create one interface for a service that you want to use, and then everywhere you need to use that service, just use the interface. Don't use the implementation, because you might have to change that and put it somewhere else,
Right.
add another implementation in. We've gone away from that. Why? Because we were taking a hit in terms of complexity. We were adding complexity so that in the future we might save on some refactoring. Well, the industry learned, well, you might as well do that work then, because when we are refactoring, we are going to be making some changes anyway. So
Right.
I think the choice of patterns has also shifted along with our values, right? We value readability and maintainability and less complexity now, as
Right.
opposed to thinking 5 years down the line. We don't think 5 years down the line anymore when we are designing those systems. So
Absolutely.
that's I think an interesting change in the way we think about patterns itself that I wanted to highlight.
Absolutely, absolutely. And also, like the way you are explaining it, like some of the most important things related to programming would be probably readability, like probably having less complexity, having less duplication, uh, and like having good unit tests so that you can maintain them. And what I actually saw in my experience was, once you focus on these four, the patterns would anyway be a result of your implementation. So if you take these four things, or the most important parts of not having duplication, reducing complexity, uh, and like kind of making sure that only the changing parts, I mean the parts which are changing, you want to separate them out. If you apply these, I see that patterns are a result of that. So somehow I feel like if you gain sufficient experience with doing the right things, uh, patterns will result from that. And that I saw in my experience as well. Sometimes I implement something, then I would see, okay, there's a pattern where this is described, but obviously the pattern is much more well written, much more well documented than what we do, but patterns are kind of results of doing something well as well.
Did you
Is
find
that
that
something?
funny how that's cyclical? You're supposed to apply a pattern and get this result. What you're saying is pretty much the opposite. You're seeking a result, and what you've applied ends up falling into one of these pattern buckets. So that's the cycle there. So
Exactly.
that's, yeah.
Exactly, because most of the things I would say in software, like we always have this conversation, right? Principles versus standards or patterns, right? So I feel like standard, for example, complexity of a method cannot be greater than 10. That's a standard, but actually that results from a principle that your code should be easy to understand. And the fact that you have a standard saying it should be 10 doesn't mean every method which is having complexity of 10 or less is easy to understand. Right? So that's where like I feel like the context, like when we have a pattern or a standard, like the context to it is much more important, and understanding the principles and trying to apply the principles will some way in long run will lead to like the good result at the end.
Yeah, adding to Kaushik's point, right? When you are adding any design patterns or some complexity to your code, there should be a justification of cost versus benefit. Just because you know the patterns doesn't mean you should apply all those patterns, because when I look back and when I see as a junior developer, right, when I want to learn, I find some open source project and I want to learn. If it looks simpler, there is nothing much to learn. Let me find some complex project where all these patterns are used and all. But now when I think about it, no, it should be the other way around. I want to build things in a simpler way. Just because something is complex, where we have all kinds of patterns used glued to one to another, it looks appreciative, and oh, there are very talented people designed by so much talented folks. Now I see If the code base is as simple as that, that is the ultimate goal of it. Uh, it should be the way.
Exactly.
So I don't really try to think of, okay, let me apply what pattern is suitable. I just go with the simplest possible solution. As I
Yeah,
mentioned, if that problem requires a pattern, you will get to know. You don't have to think about it. It will tell you, okay, I need this implementation. So
exactly.
yeah,
It makes perfect sense, right? So like, because especially because today we are focused on keeping it simple, avoiding complexity, kind of evolutionary design, as we call it.
again, in the age of microservices and all, there is a term called throwaway architecture. It should be as simple as that, where anybody can read it and then probably this language is not suitable for it and this framework is not suitable for it. You should be able to simply throw away it and then use and build it in a different language. So there, if you go with all these bells and whistles of applying all complex things, it will become much more difficult for anybody to resonate about it and then rewrite it.
Absolutely, absolutely, absolutely. So in terms of some of the like things which you look at when you like look at for example, right, so we have a lot of different kinds of patterns when it comes to the gang of four design patterns. We call them the creational, structural, and behavioral project patterns, right? So are there any specific patterns that you make use of? I mean, one of the frequently asked questions, like when we did this poll on YouTube community, was what are the top 5 design patterns that you make use of, right? So like, how do you answer that? Like, if let's say somebody asks you in your interview today, what are the 5 top most design patterns like you made use of? How do you approach that? Kaushik?
I'll say I don't know, or maybe why do you want to know that would be my question. Uh, like if somebody is asking out of curiosity, that's great. But if somebody is asking this in an interview, I'd be like, I would be concerned. It's like it's not a good interview question.
Yeah.
No, I think since patterns are embedded into our frameworks of choice and
Mhm.
presented to us, our top used patterns are dependent on our top used frameworks and framework features.
Yeah.
So, for example, I use Spring Boot a lot. So, guess what pattern I use a lot? I use dependency injection. I use
Right.
singleton, and if I use JDBC template, I use the template pattern. So, yeah, I think it's kind of just those choices are made for us.
Yeah.
But I think as we use the framework and as we write code, there are some patterns which surface. I don't have a running count of how many times I've used a pattern. So these are some common ones we tend to use a lot. There
Mhm.
are some which are a little more, it's like we tend to use it for our class. Like, for example, builder pattern, right? You do see builder pattern in APIs, but when I'm trying to create something where I have to do a bunch of setters, like I prefer to use a builder pattern. I don't use a factory pattern so much. Factory pattern was initially used a lot with Spring, but now that part, even though Spring does have factories, that part is kind of abstracted out, so we don't directly use it. But build a pattern is one thing that comes to mind that I usually reach for when I have to set a lot of these things, and the setting is conditional, so I can have like a builder, put all those things into the builder, and then create objects out of it. So those are some things that come to mind.
Perfect. Cool. Shiva, you have uh, any specific patterns you want to highlight?
Uh, Same, like if you are using Spring, it already using factory pattern. It's already
Right.
using proxy pattern. For all this transaction handling and security and everything, proxy pattern is being used by Spring.
Right.
And builder, again, we don't write by hand. We use Lambda builder annotation, and it has all these features.
Mhm.
And yeah, again, one pattern that most of the times I get to use is adapter pattern because most of the
Yeah.
systems integrations and uh, and the strategy pattern, again, if you have a multiple customizations per client, if you are building
Yeah.
any multi-tenancy in a application and you want flexibility, that is one pattern to think about. And yeah, I think among all these structural pattern, behavioral patterns, and all those things, hardly maybe 7, 8. There could be 20 plus or something. but
Absolutely.
hardly 7 or 8. There is a pattern called flyweight. I never get to use that.
Right.
I most likely might not use elsewhere. So
Yeah.
hardly there could be 8 or 10 that you want to know, and maybe you write by yourself only 2 or 3, because rest of the things are taken care by your friend.
Yeah, absolutely, absolutely. You were talking about flyweight. Flyweight is in, like, for example, like your fundamental, like primitive classes, like
Yeah, value
integers.
objects. Yeah.
Yeah, exactly. That's one place where it's made use of. So we are making use of it, but as you say, it's not important that we know that anymore. It like
Yeah, I would also challenge the notion that we use these patterns because we use the framework. So for example, Shiva, you mentioned the proxy pattern, right? Yes, if I use Spring and Spring uses proxies. So does that mean that I have used the proxy pattern? I shouldn't even be aware that the object that I'm getting is a proxy, right? Unless you
exactly.
go learn about the internals, you're just treating it as an object.
Yeah,
So I wouldn't even count it as like, yeah, I use the proxy pattern. The
yeah,
usage of a pattern is where you're applying it for a solution. So the proxy pattern here has been applied by the creators of the framework to solve a problem so that they give an experience for the framework the way you feel it. So yeah, I wouldn't even count it as us applying that pattern, right? Because the
absolutely.
framework is doing that. Yeah.
Yeah, and I guess that's a result of one of the most important principles in software engineering: abstraction. Right, so you'd want to abstract as many low level details as possible so that you can focus on the most important things at that particular layer. And probably, I think that's probably something we want to touch upon, right? Because the focus is a lot of times on patterns and not on the actual principles, which are much much more important than the patterns themselves. uh, Kaushik, do you want to start with an overview of abstraction and where do you see it? I mean, I know it's a very, very difficult question because there is no place in computer science where abstraction is not used at all. So, yeah, let's just touch upon a little bit around what is abstraction.
Abstraction is a way for, like, you have, I'm going to back up a little bit. With any code, you can kind of think of it as a consumer and a provider, right? So there is a provider, which is some code or some piece of component which is doing the work, and then there is a consumer, which is depending on the provider to get something done. Okay, think of a library call, right? You're using a library, making a function call. So the library is the producer, and you are writing code, which is the consumer. So the idea of abstraction, the way I think about it, is the consumer, which is depending on the producer for the job, only needs to know what is required for it to communicate the job to the producer and not anything more. Okay, so none of the internal details of whatever is actually doing the work needs
Right.
to be aware. And we see this abstraction everywhere, right? So I'm looking at a computer monitor. I have no idea what it takes to build a computer monitor. I have no idea I have
Exactly.
some idea that, okay, there are some rays which hit the LCD screen, it emits light. Just I happen to learn it. But is it necessary to use a computer monitor? Absolutely not. So all the internal workings of this monitor that's in front of me is abstracted away in a nice chassis that the manufacturer has created. And all I need to do is press the button to choose the mode, and that's about it, right? So
Absolutely.
the concept of abstraction is hide the implementation details which is not necessary for a user or a consumer to know about,
Yeah.
and hide it behind a short and easy to understand interface
Mhm.
that the consumer interacts with. For
Right.
there to be abstraction, there has to be an interface, because without the interface, all the nasty details of the abstraction are visible. So the interface is what hides it. So this interface and abstraction work together for us to make sense of complex computer systems, right? I can depend on somebody else's work because they have abstracted it away and I don't have to know about the details. I just call APIs and get work done. And similarly, when I'm writing a library, I hide my implementation details so that whoever is consuming it is
Mhm.
only dealing with an interface. Too long an explanation, I'm sorry, but that's my that's my understanding of abstraction.
But I think understanding abstraction is the fundamental to software programming, right? So it's the core of what we do as programmers, right? Earlier we used to, like, even if you look at the evolution of languages, like all that computers understand is zeros and ones, and assembly language, low level languages, high level languages. And today most of us, I mean 95% of us, use some kind of a high level language to program. That's abstraction as well. And whenever we design something, whenever we architect something, whenever we code something, I think abstraction plays a crucial role. Shiva, another principle which I see playing a very, very important role when it comes to software is the principle of single responsibility, right? Having a clear responsibility for everything that you create. Do you want to touch upon it?
Yeah, s- again, this is a topic which already discussed a lot in tech community. Like, if you are creating any component, be it a class, be it a method, or anything, if there is only one reason to change it, kind of we can say it is following a single responsibility. Because if there is a change in that responsibility, you got to change this one. Or if you are changing it for many reasons, it is doing many things. So either you break it up, and then there is always some kind of a higher level composition happens. Maybe it is as a higher level you do certain tasks which involves doing multiple steps. Probably each step can be implemented as a separate step, which is taken care of as a single responsibility. But again, this is one pattern or principle that you need to apply for achieving readability of your code. If you are splitting up your code, doing one thing by one class or method, it is very easy to reason about the code and then understand it. So it is linked back to this readability of aspect of it. Yeah, I
Absolutely.
think that is very important. Even if you forget all kinds of design patterns, just
Yeah.
remember the single responsibility principle. This is a very important thing to understand.
Absolutely, absolutely. I agree. So it's basically like there should be one reason to change for any level, like whether we are talking about a method or a class. At understanding this takes a little bit of time. I think getting used to the applying it and finding like understanding it does take a lot of time. But I think that's, as you say, Shiva, like is a very, very important thing for programmers to understand, like understanding the
One
single response.
one approach I follow is, let's say I am exploring some existing code base. Okay, to get a feel of whether we have this single responsibility or not. Suppose you want to understand how one particular REST API endpoint is working, and you follow through all the API endpoints, and then you land up on a say one service method. If you can just glance at a service method and then understand what it is doing with just a few lines of code,
Yeah,
that is kind of a, in a way, it tells you that it is following single responsibility principle. Because if you break down all those subtasks into either in a private method or delegate to respective classes, you should be able to see those high level steps. You don't have to go into the details of implementation. You
yeah,
can just take a glance at the high level method and see, okay, this is what we do. Maybe I'm interested in the step 7. I will go into that
exactly.
method directly. I don't bother about all these first 1 to 5 6. Okay, so that's a indicator to say, okay, we have a good abstraction and we have a single responsibility. That's how
Absolutely.
it's like.
Absolutely. I think what, like the name you give to a variable or a method or a class, if it represents all that your class is doing or a method is doing, that itself is a good representation of the single responsibility principle, right? So, if you are doing too many things, you might need to give a complex name, and that kinds of tells you, okay, maybe you are doing something.
If you
Maybe,
are if you have to use and or keywords in your method name, that's an
yeah,
indication.
absolutely, absolutely. That's awesome. Kaushik, you have anything to add there on single responsibility?
No, that's a great way to look at it. You earlier talked about method lengths, right? One of the other things is like these two again are cyclical. If you follow the single responsibility principle, you're not going to have this huge methods which do 100 different things, right? You automatically end up with smaller methods which are more maintainable and easier to read. So there are positive side effects all along if you do this. So that's one of the reasons why it is the popular pattern that it is.
Absolutely, absolutely. And for viewers out there, like what I'm talking about in here are some of the important principles. Like there are solid principles, 4 principles of simple design. So maybe those are the best places for you to start off, rather than focusing on design patterns when you are starting off. Is that like Koushik? Is that how you see it as well? Like start with
Yeah.
something basic.
Yeah, no, I honestly I see all of these as patterns, right? So these are common advices to solving these problems. Of course, you can say, okay, only what's in the Gang of Four book is patterns, everything else is not. But these are common ways to approach and common things to keep in mind. So yeah, these are all things that would be great starting point for somebody to learn.
Awesome, awesome. Let's another important pattern you touched upon was dependency injection, right, Kaushik? I think that also is a very, I mean, it's not a pattern; it's maybe a principle. Uh, Basically, like to separate out the dependencies and inject them in. I think that also brought a huge change in how we approach building software. Right now, I feel like the software which we build today is much more testable and much more simple just because of the dependency injection principle. uh, do you want to add anything there?
Yeah, no, and again, I tend to look at this as a pattern, right? Dependency injection, like
Okay.
designing classes to be dependency injectable,
Yeah.
is a pattern in my book. Again, not scientific. It's probably not in the Gang of Four list, but it is
Right.
a pattern because you do have a way to solve the problem of how do I get hold of instances and still make things easy to test. Also, dependency injection is, here's an interesting thing about all these patterns, right? There's this thing called the pattern language, which are like a bunch of patterns that go well together. And dependency injection, I think, was like an obvious choice to make for a framework like Spring, because some other patterns did end up with problems. So take the singleton, for example. A singleton is a pattern that you apply for when you need one instance of something. Well, like we mentioned earlier, every pattern comes with a cost. Every pattern you apply has its drawbacks. The drawback for a singleton pattern is if there is only one instance and you've kind of sealed off all the ways to access it, how does somebody who needs that singleton instance get it, right? So we used to have kind of like a hacky way of, okay, you're going to have a static member variable here and that's going to have it. It's a hack, right? It's, you wouldn't want that. It's just a workaround, kind of depending on the language's static behavior in order to make this work. So a pattern also has a drawback. And
Mm.
usually there are other ways to address the drawback, which are also patterns. So, in case in point, when you have something as a singleton, instead of having the static variable and having the code be affected as a result, you can have the code be transparent, or ignorant of the fact that it is a singleton, right? No
Right.
traces of it being a singleton in the class. But then you have a dependency injection pattern which takes care of injecting it. So you see those two work together. The problem created by the singleton pattern was solved by the dependency injection pattern to make sure that the class is a singleton, but still the instance is easy to inject. So
Yeah.
that was my first aha moment when I learned dependency injection. Injection is like, yeah, this is a problem, and they've solved this way. But yeah, dependency injection is great because of the other benefit that you mentioned, which is that it is also allows for testability,
Yeah.
and you can write better code because now you don't have coupling between classes, and you also have better testability. And it's introduced in Spring. I also see in a lot of other use cases, like even in front end technologies like
Yeah.
Angular uses dependency
Absolutely.
injection. So it's used in a lot of different places and a very useful pattern.
Absolutely. And
One,
like the way you explained it, you also see abstraction in play, because it's abstracted away, and also single
Yeah,
responsibility principle in way. So
exactly.
yeah,
Yeah.
I think a lot of these principles come in whenever we try and implement something. Shiva, you have something to add?
yeah, one challenge is with understanding dependency injection. The problem is like when we explain, okay, this is the dependency injection principle, instead of looking up or creating the dependencies of one component by itself, it should be injected into this one. Most of the times, some people say, so it is all for testing. I need to do all this because I want to just test this. Do I need all this complexity just for testing? It is not only enables you to test it, if uh, this is the tricky part, unless people have a reason where they want to switch the implementation, it is hard for them to realize. They may think, oh, we need to do all this magic because of just for the sake of testing. But let's say if you are building a product and you are trying to give some kind of a flexibility for end users, they want to switch some kind of a implementation. They don't want to integrate with one service provider. They want to integrate with some other service provider. If you have this dependency injection and you have this external implementation, so, say as a library, so using this dependency injection mechanism, you can just compose at the dependencies, you can switch them. So that's when people start realizing, okay, it is not just for testing, it enables you to build a product and you can integrate with, you can switch the service provider plugins.
Absolutely,
So
absolutely.
that's where you can realize the importance of dependency injection.
Yeah, and also I see that it reduces the complexity and it's much more readable code. I feel like if you use dependency injection properly, your code is much more readable than it is when it is not used. And also today, dependency injection is kind of free, right? Earlier, at least you, if you had to do the setup, then it was difficult. But now Spring does it for you. All that you need to do is to use the right annotations, probably create the right constructors, and that's it. Like everything is taken care of for you. Awesome, awesome. Let's probably pick up a few questions um, from here. Probably we covered most of these. Like uh, Shiva, Kaushik, I mean, do you want to pick up any of these things? Like probably how important is it to learn design patterns as a fresher new graduate? I think we talked about it extensively. Uh, I think we touched upon the interview aspect as well. Like you had the answer from Kaushik there. Yeah, top five design patterns. Where can I start? How can I apply design? I think we touched upon most of these questions. To end the discussion, Kaushik, probably like a word on where somebody can start if they want to learn design patterns. Somebody's hell bent, like even after this entire conversation, they would want to understand everything about design patterns. Where can they start?
Oh, the Head First design pattern book is an absolutely, it's gold. I love the Head First series. A lot of their books are amazing to read, and plus one to your recommendation of reading. And it's not bad to read this. I mean, you're welcome to read and learn and know about design patterns. Just don't have it be the end, right? Design patterns are a means to an end. Just don't learn
Yeah,
design patterns and start applying it. It's a different mindset, because you think about learning technology and like, yeah, I want to do something with the technology. You don't do that with design patterns. You learn design
right.
patterns and just keep it in the back of your head. You don't go ahead and use it at every chance you get, but as long as you know that, please go ahead and learn them. It's you feel some kind of happiness once you learn a pattern, why it works, why they have recommended that way. You kind of understand the pros and cons, and you kind of get that appreciation of, just like listening to good music or reading something, looking at a good painting or reading a good book. It's like you admire the thought and creativity that's gone into creating these patterns.
Exactly.
It's a lot of fun, so please read and learn about it.
Yeah,
Just don't use it as like an excuse for trying new stuff. Just something in the back of your mind to use, and you will know it when the timing is right. So
yeah.
start with Head First Design Patterns book. I wouldn't recommend the Gang of Four book, honestly. I haven't read it completely yet. I would also look at other articles. There are a lot of YouTube videos which cover design patterns, or even go to the Wikipedia page for design patterns. There are a lot of patterns outlined with definition. Just read those, gather as much knowledge as you enjoy, and that's what I would recommend.
Yeah, I
Yeah,
think you made a very, very important point there, Kaushik. I think you said the why. I mean, it's not the result which is important, but why is that result a good solution for that specific problem? I think thinking that and like then you would understand the beauty of thought, as you'd say, like beauty of the solution. Understanding that will help you become a better software programmer. Awesome, awesome, lovely. Shiva,
yeah, yeah. So the Head First Design Pattern book, that is wonderful book. If you have plenty of time, you not only it's a fun read, not only because of the explanation. There is some jokes and conversations, funny conversations. It's a funny read. It's not only informative. It's a funny read, but it will take a lot of time. If you want to just get a gist of what this pattern does and all, there is a site called, I think, sourcemaking.com or something like that. Sourcemaking.com.
Yeah.
So that site has a kind of a concise explanation of design patterns. You can read about it, and I think it has kind of some sample implementation, things like that. But this is all for being familiar with those patterns. But if you truly want to understand, I think you can explore some of the libraries in your favorite language where they employ this. That is the best learning, where you actually gain the real-time experience of, okay, this is how we can implement. If for Java developers, I would strongly recommend read Spring JDBC module, where we have this JDBC template. That's the best way to understand template design pattern. You can explore any connection pool library where you can understand how this proxy pattern works and how builder pattern works. They employ a lot of these patterns into this building this library. So that's when you can learn practically, not just theoretically.
Absolutely, absolutely lovely. So start with head first design patterns, understand the why, and like also dig deeper into frameworks. So that's a couple of recommendations from the experts out here. Thanks a lot, Kaushik. Thanks a lot, Shiva, for your time. And I hope I'll see you guys again very, very soon.
Thank you, Ranga. Always a pleasure.
Watching this video is a great first step. How do you remember what you have learned in this video for a long time? Pause, review, and write down the 3 most important takeaways from this video and post them in the comments. What's more, 5 lucky winners win free access to one of our amazing courses. So pause, post the comment, and continue. And do not forget to subscribe. Go ahead. I'm waiting. Thank you. Keep learning every day. Keep learning in 28 minutes.